Okay, lesson number 5, trinomial factoring 1, where a equals 1. You're like, what does that mean, miss? Well, trinomials, we're looking at trinomials, and we're looking at a very specific kind of trinomial. We're looking at the trinomial in the form ax squared plus bx plus c. So it's a very specific kind of trinomial. In that, the leading coefficient is in front of the highest term. So what we're talking about for these ones are where that leading coefficient a equals 1. So it's no number other than 1. So this is our standard form of a trinomial, ax squared plus bx plus c, where a is not equal to 0. So there has to be an x squared in there. It might be a 1x squared, a 2x squared, but we're just talking about the 1x squareds. Now in this, a and b are coefficients, c is a constant, so there's no variable with c. And the degree of the polynomial is 2, the highest degree, because x is squared. So the leading coefficient in this case is a. Now factoring trinomials is the reverse of multiplying binomials. Remember, we've already learned FOIL. So if we have two factors, two binomials that we are multiplying, x plus 4 times x times 3. If we're looking at our result, this is, let me just tidy that up. Here we have, this would be our first, our outer, our inner, last, if we were to multiply those. First is x times x, which is x squared. Outer would be x times 3, which is 3x. Inner would be 4x, right? And last would be 4 times 3. Remember, we always have to combine our like terms. So when we do this, we get a trinomial because the 3x and the 4x add up to 7x. Okay, so we know how to go this way. When we're factoring, we're going to go the opposite direction. We're going to start with the trinomial and try and figure out what the binomials were that made it. Once we find the factors, here's a cool thing. We can FOIL those factors to see and check if we get the trinomial that we started with. So it's one of those neat math things where you can always check what you've already done. Now, there's several different types of trinomials that we're going to be asked to factor. However, the number one rule, regardless of what you're doing, is always common factor first. Take out the greatest common factor to simplify it. It's going to make your life easier. As well, if the leading coefficient is negative, you want to factor out a -1, okay? You may have to rearrange the terms. So, factoring the trinomials in the form ax squared plus bx plus c when a equals 1 is the easiest kind of factoring. The big thing we learn is that whatever numbers are here in your binomials, it adds together to give you your middle term, right? So where we had this one up here where we had a 4 and a 3, positive 4 and a positive 3, when we added them together, we got our middle term of 7, okay? And then the other thing is that those two terms will multiply, oops, wrong, I want to use the fuzzy, multiply to give you the last term, okay? Because, and let's see how that works. 4 times 3 multiplied together gave us 12, right? So our middle and our last term come from that portion of the binomials, the two latter terms in the binomials, okay? So we're going to use that pattern to help us factor. There's a lot of if-thens. If this is this, then this is this. Okay? So, and again, practice is how we learn this. Examples. I'm going to talk about a system. We're going to get there. First step, factor out a GCF if possible. And if there's a negative in the leading coefficient, you factor that out. Okay? You cannot have a negative there. Don't forget to include the GCF as part of your final answer. Remember, the first thing you do is write the GCF outside the brackets. It's got to stay there. We need to know it's one of the factors. We're going to state the product the last term, state the sum, the coefficient on the middle term, and then determine two factors that multiply to be the product and add to be the sum, okay? So that's kind of the trick, and you're going, huh, what? Don't worry, we're going to walk through it. So they multiply to be the product and add to be the sum, okay? Now these numbers are going to be the same. They have to be two identical factors that will get you there. When you've done that, you're going to create your binomial factors using those variables and insert them into the end of each binomial. Then we can, and this is a good at the beginning, check your work by expanding by FOIL to get those two binomial factors. So let's see how this works. So we have these terms here, so let's highlight them, right? Let's highlight them actually in different colors, just to kind of keep us sorted. So 10 is here, and 16 is there. So I want two identical numbers that multiply to give me 16 and add up to 10. So we did all that work with factoring, right? I can get 16 a number of ways, right? 16 would be 2 times 8. It would be 4 times 4. It would be 1 times 16. So looking at those factors of 16, are there two factors that add up to 10? And lo and behold, there are 2 and 8. 2 times 8 is 16, and 2 plus 8 equals 10. And you're saying, okay, yeah, sure, miss. What do I do now? Well, now we take those two, and remember our binomials, these are both positive, so they're both going to be positive numbers, or pluses. So we're just going to plop those in, 2 and 8. Okay, so this gives us our last term, and this gives us the coefficient on the middle term. Now, you're saying to yourself, okay, but how do you know if that's right, miss? Well, we're going to FOIL to check. Okay, x times x is x squared. X times 8 is 8x. 2 times x is 2x. And 2 times 8 is 16. Now we're going to combine those for our middle term. X squared plus 10x plus 16. So check. We've got the right answer. Yay! Alrighty, so we can draw ourselves a happy face, whatever we need to do to make us feel good about the fact that we got the right answer, okay? Let's try this again. Now you don't know, I'm not always going to provide you this little chart, so you might want to make that up yourself. So let's think. We want two factors that multiply to give me 18 and add up to negative 11. So, and one is negative and one is positive. Or no, actually, because 18 is positive, they have to both be negative. So, 18, we would get negative 1 times negative 18. Well, that doesn't work. It could be negative 2 times negative 9. Wait a minute. I think that works, doesn't it? I could keep going. I could do negative 3 times negative 6, but I'm pretty sure that negative 2 and negative 9 multiplied give me 18, positive 18, and negative 9 plus, or sorry, negative 2 plus negative 9 add up to negative 11. So watch your negative signs, okay? Very critical, because it's going to make a difference for your answers, okay? I'm going to actually just highlight those with red so that we're aware. Okay, so let's make our things. We know we're going to have A. They're both negative. So from our answers, A minus 2, A minus 9. Okay, and again, you can FOIL to check. So that might be a good thing if you want to pause the video, FOIL, and make sure I'm right. Alrighty, so what we're looking for, we need two numbers that multiply to give me negative 20 and add up to negative 18. Or do we? What is the first rule? The first rule is GCF. So I have 2p squared minus 18p minus 20. I can divide out a 2 from all of those. P squared minus 9p minus 10. Now I'm dealing with smaller numbers. Okay, so from this, I want two numbers that multiply to give me 10 and add up to negative 9. They have to multiply to give me negative 10 and add up to negative 9. So what I really want to do is I want to think about my factors of negative 10. So it could be negative 1. Oh, I don't like this pen. It's not being very nice to me. So negative 1 and positive 10. Well, that gives me a positive 9. But what about 1 and 1 and negative 10? 1 and negative 10 do add up to negative 9. So keep my 2, p plus 1, p negative 10, because these add up to negative 9, right? And again, you can FOIL to check that. Alrighty? Okay. Let's go over here. And I'm sorry about how I'm dealing with the space, but it's tight, right? Now, there's no common factor, or is there? There is. There's an a in each one of these. So we're going to take out that GCF. So a times a squared minus 17a plus 42. Okay. So remember, we want two factors that multiply to give me 42 and add up to negative 17. So 42 has to be a positive answer, and 17 has to be negative. So that means they both have to be negative, okay? So it's just remembering your integers there, right? I'm going to fix 42, okay? So here we go. I have 42, so let's list my factors. Let's see, 42 divided by 2 is 2 times 21. Well, that won't work. What about 42 divided by 3? Well, that's 3 and 14. If they're both negative, negative 3 plus negative 14 equals negative 17. So I can use that. So keep the a on the outside. We don't want to lose our GCF. Write our a's in the beginning. It's minus 3, minus 14. And how would we check this? You can check by using FOIL. Okay? So if you want to pause and check just to make sure, not a bad idea. Okay. Looking at the next one. So, do I have a common factor? Why, yes you do, miss. You can take a 5 out of everything. So 5 times x squared minus 4x plus 3. So remember, we want two numbers that multiply to give you 3 and add up to negative 4. So let's list our factors of 3. Well, it's just going to be 1 and 3. Now, to get a positive 3, they either have to be both positive or both negative. To get a negative 4, they got to be both negative. Does negative 1 plus negative 3 equal 4? Yes, it does. So we have our two numbers. So 5, x minus 1, x minus 3. And how would we check these? You could check with FOIL. Okay, so if you wanted to do that, just to make sure I'm right, go right ahead. Okay, let's do some more, because this is how we learn them. Oh, all plus signs. Those make it so much easier, and there's no common factor. So I want two numbers that multiply to give me 6 and add up to 7. So let's think about our factors of 6. So I have, the easiest one is 1 times 6. Do they add up to 7? Well, yes, they do. So x plus 1 times x plus 6, and then I'm done. And you can check by foiling. Alrighty? Okay, let's look at the next one. Here we go. So, no common factors, but they're both negative. So that means one of my terms is gonna, if this is negative 35, that means one's gotta be negative and one's gotta be positive. A lot of times what I do is I think of two factors that are going to have a difference of 2. And that's where I go from. So 35, well, 35 divided by 5 is 7. Now, if I were to make one of these negative and one positive, I would get negative 35. I'm going to make the 7 negative and the 5 positive. Why? Because positive 5 and negative 7 add up to negative 2. So it would be a plus 5, a minus 7. Now, just an interesting note. It doesn't matter what order you put these in. You could go a minus 7 times a plus 5, and these would both be right. The order is not important. They're factors, so when you're multiplying, it doesn't matter which one is first and which one is second. Okay. Alrighty. Now, we need to rearrange because we want to put it in standard form. So we're going to have negative a squared minus 12a minus 36. Now, we talked about the fact we don't want a negative sign, so I'm going to divide a negative out of every term. And I have to remember to leave it there. A squared plus 12a plus 36. Okay? Now, I'm just going to factor what's in the brackets, but I'm going to leave that I'm going to have my negative sign on the outside. So, looking at this, two factors, they're all positive, so they got to be positive factors that add up to 12. Well, the first two spring to mind for me are 6 and 6. 6 times 6 is 36. 6 plus 6 is 12. So plus 6 plus 6. This is actually a perfect square. We could also write this as a plus 6 squared because I'm multiplying the same thing times the same thing there. You don't have to. It's still correct. Okay? All right, let's do a couple more, right? Alrighty. Hopefully you're getting the hang of it. Now, this one's interesting because we have the y squared. So we want to incorporate that in to our numbers, or to our factors. We're not going to let it upset us. We're still going to just think about the numbers in the same way. It's just that this is going to have an x, and this is going to have a y. Okay? Now, we want two numbers that multiply to give me negative 36 and add up to negative 9. So one has to be positive and one has to be negative. So let's think about that. 36 divided by 3 is 3 times 12. Oh, how do I do this? So 3 times 12. Now, if I make one of those negative, they will give me a difference of 9. So which one to make negative? I'm going to make the larger one because 9 is negative. And positive 3 plus negative 12 equals negative 9. So I'm going to put those in just as they are, plus 3 and minus 12. So what you see is x plus 3y times x minus 12y. Now this one, let's FOIL just to make sure. Because we've got those y's in there, we want to check them. So it's going to be x times x, which is x squared. X times negative 12y is negative 12xy. 3y times x will be plus 3xy. And 3y times negative 12y is negative 36y squared. Now I combine my middle terms, x squared, negative 12xy plus positive 3xy is negative 9xy. And then I have my last term. So yes, it worked. Just wanted to do that, show you how those y's are in there and they don't mess anything up. Okay? Alrighty, let's do the next one. Now I'm looking at this and you're going, Miss, there's a lot of crap going on in there. And yes, there is. But we can clear it up a bit by taking out, oh, what is a GGF? It's a GCF, right? The greatest common factor. So let's look at what our greatest common factor would be. Well, definitely a 2. And an x in each term, right? There's only a y in the last two, so they don't work. So when we do that, we're left with x squared here, plus this will be 40 divided by 2 is 20, and it'll be xy. And then 200 divided by 2 is 100, and it will be just y squared, okay? So we have our 2x. We know we have an x here at the beginning. We've got those y's though, so let's write them in. Now we got to figure out the numbers. Well, we want two numbers that multiply to give you 100 and add up to 20. Well, I don't know about you, but the two that spring to mind for me are 10 and 10. 10 plus 10 is 20. 10 times 20 is 100. So plus 10y plus 10y. We can write this all out, all in the same color. But look, that's a perfect square, so I can write it like that. You don't have to, but it is. If you want to check that one, like we did the last one with FOIL to make sure that it works, please do so. Okay. We're going to find the GCF, right? So I can take out a -3 from everything. Everything's divisible by -3. And I can take out an x because everything has an x. And then I'm left with x squared minus 7x plus, what's 36 divided by 3? It's 12. Now I'm looking for two numbers that multiply to give me 12 and add up to -7. Okay, so, well, the first two numbers that spring to mind are 3 and 4. If they're both negative, they will fit this. So, -3x, x minus 3, x plus 4. And there you go. Okay. And sometimes you try more different ones. I mean, you know, it's not always that first one that comes to mind. Sometimes you have to try a whole bunch of groups of factors to get there. And of course you can FOIL to check if that is right. Okay. Dun, 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 dun. Alrighty, determine two values of C that allow each expression to be factored. What? Well, now we're playing around with possibilities, right? So multiple possibilities. So what we're going to do for this is we're going to think about factors of -8 and what they would give us as answers. So I could have -2 times 4, right? So if that is what I have and I added them, -2 plus 4 would be +2. So that means that, oh, yeah. So x squared, if it's minus c, would be -cx minus 8. It's kind of tricky, right? Or, oh, I see they want C to not have an answer. Ooh, we got to have a bigger number. Never mind. Okay. You know what I'm going to do? I think they want it specifically to fit that criteria. So if I make 4 negative and I add them, I will get -2. And that would fit in there, right? 7 and 2. I get, okay. So it could be x squared minus 2x minus 8. That's a possibility because I can get -2, right? Or I could have 1 and 8 and have it like so, and it would be -7. So it'd be x squared minus 7x minus 8. So that's two possibilities for C. C could either be 2 or 7. And there's multiple answers. Technically, if C could also be a negative number, it could be -2 and -7. Now, those are the only factors of 8. If there were more factors of 8, you could have more answers. All right, so it's kind of tricky. I think it wants just the positive answers based on how the question's written. Same thing here. So we have, sorry about that, I bounced around. Yep, right here. So again, we're looking for two numbers that multiply this to add up to get this. So if I think about 4 and I think about my factors, well, I could have 1 and 4, and I could have 2 and 2, right? So they have to give me a positive 4, so they have to be both negative. So this would add up to -5, and this would add up to -4. So that would mean that C would either be 5 or 4. Okay, so it could be y squared minus 5y plus 4, which is equal to y minus 1 times y minus 4. Or it could be y squared minus 4y plus 4, which is y minus 2 times y minus 2. So this is just trying to get you to think about factors and the total possibilities. Sometimes there's more than one answer, okay? And it's good for us for problem solving to be able to recognize that. Alrighty. So if you need to take a screen cap, pause and take a screenshot, you can do that. Take a look at the rest of it. This is the top page because I know I kind of zoom in and out and it might be easier to see the whole thing. So that's factoring trinomials. We're going to do a little practice with this. We're going to learn some different techniques.